The line L is given by the parametric equations. Find the coordinates of the point on L which is nearest to the origin. So it is given a line L, and any point on this line has coordinates 1 minus lambda, 2 minus 3 lambda, 2. And there is origin, and we need distance from the origin with coordinate 0, 0, 0 to be the closest, and the closest distance is always the perpendicular distance. And line L also has the direction vector, let it be b, and it has coordinates -1, -3, 0. It's just coefficients in front of lambda, because line can be rewritten as position vector of any point on a given line x, y, z. Coordinates of a vector is equal to position vector of any point. It's 1, 2, 2 plus parameter multiplied by the direction vector of this line. It's -1, -3, 0. And notice that it's position vector, and vector coordinates of any vector are coordinates of endpoint minus coordinates of the initial point. And since coordinates of the initial point is 0, 0, 0, hence for coordinates of a point we get the same values. They have different meanings, but values are the same. Coordinates of a point we write in a row, coordinates of a vector we write in a column. And there are two possible ways how to solve this problem. And the first is the next: to consider vector OM, and since OM is the closest distance, and hence OM vector is perpendicular to the direction vector of this line. And if two vectors are perpendicular, their dot product is equal to 0. Dot product, this formula is given in a data booklet. It's x by x plus y by y plus z by z. So we can see the dot product equated to 0 and solve for lambda. If you know lambda, you substitute and get coordinates of the required point. And if this distance required, you use formula for the distance between 2 points, or if you know vector, you apply formula magnitude of a vector. So this dot product becomes -1 multiplied by 1 minus lambda plus -3 multiplied by 2 minus 3 lambda plus 0 multiplied by 2, and is 0. We can divide by -1, so it becomes 1 minus lambda plus 6 minus 9 lambda is 0. Hence 10 lambda is 7, lambda is 7 over 10. And hence coordinates of a point become 1 minus 7 over 10, 2 minus 3 times 7, 21 over 10, 2, and hence it becomes 10 over 10 minus 7 over 10, it's 3 over 10, 2 it's 20 over 10, so it's minus 1 over 10 and 2. Another way, we can apply formula for distance between 2 points, so OM, or let it be just S, OM, S, it's a square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So it becomes 1 minus lambda minus 0 squared plus 2 minus 3 lambda minus 0 squared plus 2 minus 0 squared. And this distance must be minimum. S is minimum, and since S is minimum, S squared, or this expression on the root also must be minimum. So S squared is minimum and is minimum. And if we consider minimum or maximum, we know the derivative is equal to 0. So we can consider derivative of S squared with respect to lambda and equate it to 0 because it's the extreme point, maximum or minimum. In general, here it's minimum. So you can open parentheses and add like terms, or if you use this expression directly, you should apply chain rule 1 minus lambda squared derivative, and chain rule says that it becomes 2 1 minus lambda to the power 1 and 1 minus lambda derivative, which is negative 1, plus 2 minus 3 lambda multiplied by negative 3, because 2 minus 3 lambda derivative negative 3, plus for derivative which is 0 and is 0. And it becomes, we can divide by 2 and by negative 1 and get 1 minus lambda plus 3 2 minus 3 lambda is equal to 0. Is 1 minus lambda plus 6 minus 9 lambda is 0, hence lambda is 7 over 10, and we can see that we get absolutely the same result, and you substitute lambda into this expression and get a required point. If distance required, we apply this formula. And that's all for this question.